Hello, biology students. This is Mrs. Lorenz. We are starting a new unit today on biochemistry. So we're moving from ecology into a little bit of chemistry. We don't spend a whole lot of time in biology talking chemistry topics, but this unit we touch on it briefly. Some of this information should be reviewed for you from ninth grade physical science or even prior to that in middle school. So especially today, this information should be somewhat review for you. In this unit of biochem, we're going to review some chem terminology or some physical science terminology. We're going to talk about water properties tomorrow, and then we'll get into macromolecules, which there are 4 of. We'll spend a couple days on that, and then we'll wrap it up talking enzymes and catalysts. So that's what's to come in this biochemistry unit. Note the definition: the study of chemical processes within and relating to living things. That is biochemistry. Looking at the structure of an atom, so again, hopefully some review for most of you. If you're looking at just a generic diagram of an atom, you have your protons and neutrons inside the nucleus of the atom, so in the center. You have your electrons on the outer rings. Okay, so as far as locations, you have protons, neutrons in the nucleus, electrons on the outer rings. Protons have a positive charge. Neutrons do not have a charge, so they're considered neutral, and electrons have a negative charge. Again, thinking back to ninth grade physical science, there are only a certain amount of electrons that can be held on each energy level. So we'll get into that in a minute here. Prior to that, let's talk about some bonds. First bond we're going to refer to is the covalent bond. Covalent means together, right? So codependent, covalent means sharing or together. So in this bond, you have 2 atoms that are sharing their electrons or their outer electrons. Remember, we call those electrons in the outermost ring valence electrons. Those are the only electrons involved in bonding, or the outermost electrons. Most atoms want 8 valence electrons in their outer shell. That is considered full or complete, or some people may call it stable. So they want to bond with other atoms to complete their outer shell, which is usually 8. In this case, you have 2 atoms, each with 7. So they will bond together to share those 2 in the middle so that each of them will have 8. Most covalent bonding occurs with nonmetals, 2 or more nonmetals. So here you have O3. Oxygen obviously is a nonmetal. 3 of them together bonded, you get ozone. H2, hydrogen, H2O, water, etc. So the sharing of those outer electrons is called a covalent bond. And that's what keeps those elements together, or those atoms together. Another type of bond is called an ionic bond. These bonds are formed from oppositely charged ions being attracted to each other. So you know that opposite charges attract, and this is how it works. If you have, in this case, you have sodium, or Na, and you have chlorine, Cl. Sodium has 1 valence electron, 1 electron in its outermost ring. It wants to lose that electron to drop that entire shell and drop down to a full complete shell of 8 right here. That is where it's most stable. So sodium wants to lose an electron. Chlorine, on the other hand, wants to gain an electron because they only have 7. So they're almost complete. They just need 1 more electron to complete their outer shell of 8. So if sodium gives up an electron, they're stable because they drop down to 8 in their outer ring. And chlorine accepts that electron and fills its outer shell, so that is also stable. In that process, though, of gaining or losing electrons, you're changing the charge of that atom. So remember, electrons have a negative charge. If sodium is losing negativity, losing an electron that is negative, it becomes more positive. It has a positive charge. So once it loses that electron, because it's negative, the atom becomes positive. Chlorine, on the other hand, has gained that electron, so it has gained something negative or negativity, so it becomes negative. That positive and negative oppositely charged atoms is what holds these two atoms together. That is called an ionic bond. So a positive and a negative charged atom are going to be held together by an ionic bond. Often these are a metal and a non-metal that are combining and joining in this way. Another bond is a hydrogen bond, and we'll come back to hydrogen bonds and revisit them again probably tomorrow when we talk water properties. So a hydrogen bond exists between, well, it can exist between two water molecules. That's our example here. So H2O, so you have two water molecules here held together by a hydrogen bond. Hydrogen is more positive, oxygen is negative. And all this means is that the electrons spend more time around the oxygen in this bond than the hydrogen. So the oxygen is more negatively charged, the hydrogen is more positively charged. That attraction, again, the positive of one atom and the negative of another atom, holds these two molecules of water together. That hydrogen bond can be broken, hence why we get different states of matter. So solids to liquids to gas has to do with this hydrogen bond weakening and then breaking, forming a gas. And then our last slide for today, moving into the most common elements that make up the human body. Again, because we're talking about chemistry and living things, we need to refer to what elements make up living things. Hydrogen, carbon, oxygen, nitrogen, calcium, phosphorus. Those are our 6 most common elements. In order for something to be organic, it must contain the element carbon. Note their symbols are very simple. So these are the ones you'd see on like a periodic table. Most of them are just the first letter of the element name. So hydrogen is simply an H, carbon is C, oxygen O, nitrogen N. Calcium is actually Ca, because carbon is just C, calcium is Ca, phosphorus just P. So note the most common elements that make up human bodies, and note that carbon is the element present in organic material. That is it for notes today. The last slide on here, these are just some video clips, each approximately 3 minutes long, on hydrogen bonds, covalent and ionic bonds, and also one on water. So if you want to click on those and watch those in your leisure time, feel free.